There are discoveries that shake astronomy, discoveries that confuse astronomers, and then there are discoveries that crack open the very foundation of physics itself. These are the kinds of discoveries that leave Nobel Prize winners silent during interviews, make cosmologists close their laptops and quietly admit, "This doesn't make sense," and cause even the strongest defenders of the standard cosmological model to stop mid-sentence because the data before them simply should not exist. The James Webb Space Telescope has now delivered exactly that kind of discovery. It has revealed something so profoundly contradictory, so difficult to reconcile with current theories of galaxy formation, cosmic evolution, and the origin of matter, that scientists have been forced, reluctantly, cautiously, and in some cases publicly, to acknowledge that something about our understanding of the early universe may be incomplete. Webb has looked deeper into space than any instrument in human history. It has peered beyond the cosmic dark ages into the era when the very first stars were expected to ignite. According to existing models, this period should contain only faint, primitive galaxies slowly assembling from vast clouds of hydrogen. Instead, Webb detected objects that appeared astonishingly bright, remarkably structured, and unexpectedly massive, far more evolved than astronomers anticipated for such an early stage of cosmic history. These objects do not appear to behave like the young galaxies predicted by conventional models. They do not seem to form, evolve, or organize themselves in the expected ways. As one observation followed another, each challenging a different aspect of current cosmology, a quiet realization spread through the scientific community. Webb was not merely discovering new celestial objects, it was exposing questions that existing theories struggle to answer. The story began with what initially seemed to be an unremarkable object, a small yellowish blob hidden within one of Webb's deep-field images, almost lost among thousands of faint points of light. At first glance, nothing suggested it was extraordinary. Only one characteristic stood out. It was simply too bright. Not just unusually bright, but bright enough to challenge established luminosity models for the early universe. Astronomers initially assumed the explanation was straightforward. Perhaps the object was actually much closer than first believed, and its distance had been miscalculated, a common possibility in deep space observations. However, spectroscopic measurements quickly overturned that assumption. The object's redshift confirmed that its enormous distance was genuine. Astronomers suddenly found themselves looking at one of the most distant galaxies ever observed, existing when the universe was only about 290 million years old. Yet it looked nothing like the young, primitive galaxy they expected. Instead of appearing small, chaotic, and still forming, it seemed structured, massive, and surprisingly mature. It resembled a galaxy that had already undergone extensive evolution during an era when only the earliest building blocks of galaxies were expected to exist. Behind the scenes, this discovery raised immediate concerns. If even a single fully developed galaxy truly existed at such an early cosmic age, then current models of galaxy formation might require significant revision. Within days, Webb revealed that this object was not alone. Rather than an isolated anomaly, it became the first member of a growing population of distant objects that appeared difficult to reconcile with standard cosmological expectations. Deep-field observations from the James Webb Space Telescope were originally intended to provide a glimpse into the universe's infancy, a landscape filled with faint, scattered points of light representing the earliest stages of structure formation. But when Webb turned its infrared instruments toward some of the darkest regions of the cosmos, the picture that emerged seemed unexpectedly complex. Instead of revealing only tiny protogalaxies, Webb detected numerous compact, luminous, and apparently well-developed systems. As astronomers analyzed these observations, many concluded that the objects did not closely resemble the young galaxies predicted by standard cosmological simulations. They appeared brighter, more massive, more compact, and more organized than expected. Even more surprising was their apparent abundance. Rather than finding one or two unusual objects, Webb uncovered an entire population of distant galaxies whose properties continued to challenge existing theoretical models. One recent study identified dozens of candidate galaxies dating to roughly 200 to 400 million years after the Big Bang, a result that has sparked vigorous scientific debate about whether current models fully explain galaxy formation during the universe's earliest epochs. Some researchers have openly acknowledged that if even a fraction of these candidate galaxies are confirmed, theories describing early galaxy formation may need substantial revision. The observations raise an intriguing possibility. Perhaps galaxies assembled more rapidly than previously believed, or perhaps important physical processes remain absent from current models. This has led to one of the most significant discussions in modern cosmology. Rather than revealing a universe that gradually built complexity over immense periods of time, Webb appears to be showing a universe where some structures formed surprisingly quickly. Whether this reflects missing physics, limitations in current simulations, or entirely new mechanisms remains an active area of research. As though unexpectedly bright early galaxies were not enough, Webb has also identified several objects with unusually high star formation efficiencies. In galaxies observed today, only a fraction of the available gas is typically converted into stars, with much of the remaining material dispersed or preserved for future generations of star formation. This balance has long been considered a fundamental characteristic of galaxy evolution. However, several early objects observed by Webb appear to have converted an exceptionally large proportion of their gas into stars. If confirmed, these observations would be difficult to explain using conventional models of star formation, which predict that gas should cool, fragment, and collapse over extended periods rather than being transformed with such extraordinary efficiency.